Okay, so in this lesson we are going through algebraic equations, right? So remember that equations mean that you're solving for x, right? Solve for x. That's really what they're saying to you when you see an equation. And equations are just, before we go on continue, the key rule with equations is whatever happens on the left hand side must happen on the right hand side, right? That's the key rule with equations. So if you've done expressions, then your expressions are more of a you're simplifying based on what you have there, right? You don't bring in outside numbers or move things around. You just simplify on what is there. Equations, you are solving for x using what is also there, but then you have a bit more uh, room, mobility. Yes, that's the word I'm looking for. So the key thing that I want us to start looking at here is, with this rule of the left hand side is equal to the right hand side, and a practical variation of that is me saying 1 plus x equals to 9, right? And in this case, what we want to do is have x by themselves. That's rule number one. That's the first thing that we always want to do. We always want to have like terms by themselves. So in the end, x should be by themselves. So we should have x there, and then on the other side we should have 1 and 9. But in order for us to get 1 to the other side, you can see here that 1 is positive, right? It's there's a fake, not a fake, but there's an invisible plus sign there as positive. If it was not positive, then it would have just been negative like that, right? So once you take a positive number to the other side of the equal sign, right? If you look at the equal sign, it changes whatever symbol you have. So if you had positive 1 that side, when you take it to the other side, it would then become negative 1, right? Another way to think of it is to say 1 plus x is equal to 9, right? Then if you want to get rid of 1 here, what would you need to do to get x by themselves? To get rid of this 1, you would subtract 1, right? So you'd say 1 minus 1 there, and on the other side minus 1, right? 1 minus 1 is 0, so it's 0 plus x equals to 9 minus 1, and there you get your answer of 8, right? Then always remember, you're doing equations, so it's always easy to test your answer. Substitute your answer, the value of x, back into the question. So there we had 1 plus x equals to 9, so we're going to say 1 plus, in the place of x you put 8 equals to 9, right? Then you have your answer there. So I want us to just quickly go through these 4 examples and then just test your understanding and ensure that you're able to do these come exam time, right? So for the first one, we have 0.4x minus, so for the first one we have 0.4x minus 1,8 is equal to 0.6x plus 0.3, right? Rule number one, like we said, we want to group like terms. So like terms is 0.4x and 0.6x. Also our other like terms is negative 1.8 and positive 0.3, right? So now we know our like terms. To group them, we know that it's going to be 0.4x there, right? We need to get 0.6 to the other side. So remember, where 0.6 now is a positive, when it goes to the other side, remember it just jumps the equal side, or you can say it's positive 0.6x, so I want to subtract 0.6x here, and that cancels out that, right? No, like that, right? And then you also bring minus 0.6x this side also, right? So there we have minus 0.6x is equal to, we have positive 0.3, right? We want to bring negative 1.8, right? Remember, it's a negative, always, always, always. And then it jumps the equal sign. Same thing happens there. We can say it's positive, a negative 1.8, right? Minus 1.8. To cancel that, you'd say plus 1.8, right? Alternatively, you can say it jumps the border, it jumps the equal sign, sorry for that, and then from negative it then becomes positive, right? So positive 1.8, and there plus 1.8, right? Then you have your equation there, you simplify that. 0.4x minus 0.6x, you have negative 0.2x is equal to 0.3 plus 1.8, and that gives you 2.1, right? Now another thing, if you want x by themselves, right, by himself, by herself, if you want x by herself, right, you would need to divide, because as it is, this equation is negative 0.2 multiplied by x. It's the same thing as that, right? Negative 0.2 multiplied by x, and what we would do there is divide 0.2, negative 0.2, right? Another rule is that x can never be negative, right? See what I did here? X is not negative, so that when you substitute it back, you're substituting x. If you're substituting negative x, then you'd only be able to substitute where the equation says 1 minus x equals to whatever, 10, right? And then if you find the value of negative x, you'd substitute it into that, but we want to substitute it just using x, right? So back here, we divide by negative 0.2, that cancels out that. Please forgive my screen just doubling there, and whatever you do on the left side you do on the right side. So this side you also divide by negative 0.2, right? So let me make that a bit neat, right? So divide by negative 0.2 there, divide by negative 0.2, then you have x equals to negative 10.5, right? A lot of colors, very messy, a lot happening here, but it's our first one and I just wanted to show you how it works. Then the rule that I said here is that you can always substitute x back into the equation, like here. You can substitute x back into the equation to see if you to see that your calculation was correct, and if your calculation is correct, the left hand side is supposed to be equal to the right hand side. So what would happen here is that you'd say 0.4 bracket negative 10.5, must also include the negative, right? And then you see that anywhere there's x, you would put negative 10.5 minus 1.8 is equal to 0.6x, where there's x we put negative 10.5 plus 0, 3. And our answer there is negative 6 on the left equals to negative 6 on the right. And you know that this is correct, right? Moving on to the next one. Just the divider there. So we have 4x plus 5 equals to 2x minus 3, right? Dealing with this, we first step like terms together, right? 2x and 4x. No, why did you do that? And 4x, positive 5 and negative 3, right? So we have 4x. We need 2x to go to the other side. 2x is positive now, so when it goes over the equal sign, it then becomes negative 2x equals to negative 3x just as is, because it's already on the right hand side. 5 is positive, see the plus sign there, goes to the other side of the equal sign, it then changes to negative 5. Then we have 2x is equal to negative 3 minus 5 is negative 8. Skip the step there. We would divide on both sides by 2, right? There's no negative 2. Remember, 4x minus 2x gives us positive 2x. So you divide by the 2, and we want x by themselves. X should not be negative, x should not be 0.1x or anything, should just be x by themselves, right? What you do on the left, you do on the right. Divide by 2 on both sides, and your x is then negative 4, right? Just to quickly go through this, we substitute x into the equation, and what you have is, I'm going to use a different color. So you have 4 brackets negative 4, right? Everywhere you see x, you substitute with our answer of negative 4 plus 5, right? So 4 times negative 4 is negative 20 plus 5 is 25, right? 2 is equal to 2 in the place of x, negative 4 minus 3. 4 times negative 4 is negative 16 plus 5 is negative 11, right? Apologies for that. Negative 11, right? 2 times negative 4 is negative 8 minus 3 is negative 11, and the right hand side is equal to the left hand side. We know we're correct, right? Moving on to the next one. I'm doing these a bit quickly, but then you can slow it down, you can rewind, you can pause and try them by yourself. If you feel like you understand these already, you can pause now and try question 3 and 4 by yourself, and then apologies for that. Yeah, so you can try question 3 and question 4 by yourself, and continue the video to just check that you get the same answer, right? So question 3, we have 6x. Question 3, we have 6x minus 9 is equals to 3x plus 12, right? First of all, our like terms, we have 6x and 3x, right? We always want like terms on one side, so we'll have x on the left, 6x, 3x is positive, take it to the other side, becomes negative 3x is equal to 12 is positive, right? 9 is negative that side, take it to the other side, becomes positive 9. Then you have 6x minus 3x gives us 3x equals to 12 plus 9 equals to 21, right? Then you divide both sides by 3, divide by 3 there also, and your answer is x equals to 7, right? Again, we tested to just ensure that we are correct and we have the right answer. So in the place of x you put 7, so it's 6, 7 there, minus 9, right? 6 times 7 is 42, yes, 42, minus 9 is 35, right? And then on the other side, 42 minus 9, no, sorry, 42 minus 9 is 33. Yeah, my maths is just a bit wonky, but I'm close, right? So on the other side we have 3, substitute 7 in the place of x plus 12, right? 3 times 7 is 21 plus 12 is 33, right? If you feel like I'm like picking these numbers up from the air or out of nowhere, always remember this is maths, right? You have a calculator, substitute these numbers as they are into the calculator and it will give you the answer, right? If I'm wrong, or if you feel like I'm not on the right path, you can always double check the answers, right? With a calculator, or going through it by yourself and then seeing where you get stuck, or what differences we may have, right? And then for the last one, we have 2 brackets, right? 2 brackets x minus 3 close bracket equals to 3 open bracket x plus 1, right? So this one is not very different to the others that we did before. The only thing that happens here is that you just need to multiply into the bracket, right? Multiply into the bracket, then from there you continue, right? Remember, BODMAS brackets come first. So 2 multiplied by x gives us 2x. 2 multiplied by negative 3 gives us negative 6 equals to 3 multiplied by x gives us 3x. 3 multiplied by 1 gives us 3, right? Continuing, remember we need to group like terms, so we have 2x there. Where's our other x? Over there with 3. Erase that. Over there with 3x. So what we do is take 3x to the other side, becomes negative 3x, right? Remember, it's positive there. Then we have 3 that is positive there, right? Then we have negative 6 on the other side. Take it over the equal sign and it becomes plus 6, right? 2x minus 3x equals to negative x, or you can say negative 1x. But remember, as I said, I hope it's still there. Okay, I removed it. As I said, any number before x, I'm forgetting the name, hence I'm not saying it, but any number before x is just that number multiplied by x. So if you have 2x like here, it's just 2 multiplied by x, right? And then in this case, negative x is negative 1 multiplied by x. But if there's 1, you don't need to add 1. The same way, if you just have x, it's the same as 1 multiplied by x. It's the same thing. So in the case of negative 1 multiplied by x, all we do is say negative x, right? Then is equal to x plus 6, right? I mean 3 plus 6, sorry. 3 plus 6 gives us 9, right? Now, back to what I just said now. Negative x is the same as negative 1 multiplied by x. If we want x by themselves, we're going to divide by negative 1. That cancels out that, and you're left with x by themselves. So same thing's going to happen here. You're going to divide by negative 1. Divide by negative 1. Right? Then you finally get x by themselves. It's x equals to 9 divided by negative 1 gives you negative 9. And that's your answer. Right? Remember, last part, we substitute back into so that we can confirm. So we have 2 open bracket. In the place of x, we put negative 9. Then we say minus 3 close bracket is equal to 3 open bracket negative 9 plus 1 there, right? Starting with the left hand side, I'm going to solve what's in the bracket first. So negative 9 minus 3 is negative 11, no, negative 12, sorry. Negative 12 multiplied by 2 is negative 24, right? Don't know where my 4 went. And on the other side, negative 9 plus 1 is going to give us negative 8. Negative 8 times 3, 8, 16, 24. Negative 24. And there you go, right? 4 of these quick examples. I might have gone a bit fast here and there, but can always come back to the first one where I tried to break it down, and then the others you can refer to as an examples or so forth, to ensure that you got to the right answer. Always remember, if you're trying this by yourself, just double check that your answer is correct by substituting back into the original equation, and you should be able to find that the left hand side is equal to the right hand side. Thank you.